Okay, so what in the world connects ancient writing, the code of life itself, and the future of artificial intelligence? Well, it's this single, incredibly powerful idea called universality. And once you grasp it, it doesn't just explain the world, it totally changes how you see progress. Let's dive in and see what that really means.
You hear about it all the time, right? AI can beat the world champion at chess, it can drive a car, it can even write music. The list of things it can do just keeps getting longer and longer. But here's the big question. Is a really, really long list of skills the same thing as true general intelligence? So let's get this straight. There's a huge difference here. Narrow AI, well, that's programmed for very specific known tasks. It's a specialist. But a true artificial general intelligence, or AGI, that's a whole different ballgame. It's not just a collection of programs. It needs to be able to solve problems we don't even have a name for yet.
All right, here's our roadmap for this explainer. First, we're going to look beyond that simple list of tasks. Then we'll see the incredible power of an alphabet. We'll trace the path from simple tally marks all the way to modern computers, explore life's mysterious universal code, and then finally, we'll get to the most important part, what it means for us to be universal explainers.
So let's jump right into that first idea. To really understand what we're talking about with AGI, we have to move beyond just a checklist of things it can do. This is about a fundamental shift, a leap in what's even possible. And here's the crucial point. A universal system isn't just a giant library of all the answers we already know. No, it's a system that can simulate any other system. And that right there gives it the creative spark to tackle problems that haven't even been thought of yet.
To really see how this works, let's look at the most perfect, most intuitive example of universality ever discovered. It's something you use literally every single day of your life, the alphabet. Think about early writing systems, like pictograms. They were pretty limited, right? One symbol meant one concept, like sun or king. So if you had a new idea, well, you had to invent a whole new symbol. But an alphabet? Oh man, with just a couple dozen letters, we can rearrange them to express a literally infinite number of ideas. That is the jump to universality.
This right here is what we call the jump to universality. It's that moment when a system makes a seemingly small change, like going from pictures to letters, and then, boom, suddenly its potential just explodes into infinity. And what's so wild is that a lot of these breakthroughs happen by accident, while someone's just trying to solve a tiny local problem.
And you know, this pattern isn't just about language. Not at all. We see the exact same kind of jump in the history of how we've handled numbers and built machines. I mean, just think about this progression. You start with tally marks. Super simple, but kind of limited. Roman numerals. They're a step up for sure, but they're super clunky for doing any real math. Then, way back in the 1820s, this guy, Charles Babbage, designed something called the analytical engine. It was a machine that, in theory, could compute anything that was computable. That was the leap. That was the jump to a universal machine. Now, Babbage's brilliant colleague, Ada Lovelace, saw its incredible potential, but she also raised a really famous objection. She said, look, it can only follow orders. It can't create anything new. But here's the one thing she might have overlooked: the universality of physics itself. I mean, if a brain just operates according to the laws of physics, then a universal computer could, in principle, simulate that brain. So what's the secret ingredient that makes all this work? What unlocks this power? It's error correction. See, old analog computers were fragile. Tiny errors would build up and ruin the calculation. But digital systems? Think of a cog clicking perfectly into place. They can check for errors and correct them. As the physicist David Deutsch says, this simple ability, that's the beginning of infinity. So far, we've only been talking about things that humans invented, but the most profound, most mysterious jump to universality happened long, long before us. It's encoded in the very fabric of life itself, DNA. To put it simply, DNA is basically the programming language for life. It holds all the instructions to build an organism, to control all its chemistry, and most importantly, to make a perfect copy of itself. It's a self-replicating universal system. But here is the absolute mystery. After this unbelievably powerful genetic code appeared, for 1 billion years, 1 billion, evolution did almost nothing with it. For all that time, the planet was just covered in simple bacteria. That was it. The universal potential was there, just sitting dormant. And this is what's just so mind-boggling about the reach of DNA. The very same basic language that evolved to build a single microbe, also had the power to specify everything that came later: brains, wings, entire immune systems. It was a truly universal code for building any kind of life. And that brings us to the final, and maybe the most significant jump to universality. This is one that took place inside the very life that DNA created. This is the jump to what we are.
The physicist David Deutsch puts it perfectly. He argues that the most important kind of universality that we know of belongs to people. We aren't just universal computers, we are universal explainers.
So what does that actually mean? Well, it means we have the potential to understand anything in the universe that is understandable. And that ability, the ability to create explanations, that's the root of all our creativity. Because we can explain the world, we can also change it. We become universal constructors. And in the end, that ability to understand and adapt is the only thing that can guarantee our survival in the long run.
So let's bring this all the way back to where we started. A universal computer like the AI we have today is not a universal explainer. The jump from the narrow AI we see now to a true AGI isn't just about more data or faster chips, it's about a fundamental leap to creativity, the ability to generate completely new explanations. And this leaves us with a pretty powerful thought. As universal explainers, our potential is in principle unbounded. The only real limit is what we can understand. So the question isn't what problems can we solve, it's what problems will we choose to solve next.